Hey everyone, thanks for joining us for the next session of our Spotlight on GitHub Advanced Security series, GitHub Advanced Security Overview for 2025. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our speaker today, Leonardo. Thank you for joining us.
Cool. Yeah, thanks for having me. This is, I think, the third Microsoft Reactor session I've done, so I'm very excited to be here. Do you want to just jump right in and start? All right, that is absolutely what we're doing. So for today, what I'm going to be talking about is GitHub Advanced Security. And so I'm going to walk you all through a demo from end to end, what sort of features come along with Advanced Security, what sort of things can we do with Advanced Security, and what does it look like from a developer perspective as well as from a security person's perspective, since everyone's working together in order to make sure that we have a much better application security program in our environments here. But before that, just a little bit about me. So my name is Leonardo Gimbaya. I am a field security specialist here at GitHub. And so my role here is really to help with the sales and adoption of GitHub Advanced Security from a technical perspective. So as someone would say, I'm the demo monkey and I do the monkey things with the demos. And that's what I'm gonna do for you all today. So let's begin with just a really quick primer on what sort of things you do get with Advanced Security. So you can see here on the left side navigation, I have three specific sections. So I have dependabot, I have code scanning, and I have secret scanning. When you have advanced security licenses, or you're going to be using advanced security in a metered basis, as in you sort of pay by the as in terms of usage, like how much usage you get is what you pay for. What you're essentially getting is going to be three of these specific things: our SCA. So it's going to be dependabot, dependency review, dependency graph, and insights. It's going to be code scanning, which is sort of an umbrella where we have our own static analysis tool called CodeQL that uploads data to that. And then we also have the ability for other tools to integrate into GitHub to be able to share that information inside of code scanning. So those types of alerts and those types of issues that you want to bring up to your developers, whether that might be through linters or other static analysis tool sets, container scanners, and even like third-party tools like Endor Labs, for example, they have a really good integration with us. JFrog is another partner of ours, and they have some really good integrations that they upload into code scanning for developers to sort of see that information all in sort of one place. And we have a number of different partners that we work with that all sort of use this particular method in order to get the most relevant security information as well as code information to developers where they're already working on the code itself. And then lastly, secret scanning. And for secret scanning, it's essentially we are looking for specific patterns within your environments that are what we call like partnered patterns. So AWS, Azure, Google Cloud, Stripe, Salesforce, Slack. It runs a whole list of different partners that have specific patterns for their tokens. So we're able to identify those. We're also able to prevent developers from pushing more secrets to the repositories via push protection. But we also look for other things, such as what we call non-partnered tokens. In this case, like bearer token, HTTP bearer tokens, RSA keys, things of that nature, that they do have a particular pattern, but they are not owned by any particular company or service, and they don't give access to any particular company or service. It's more of a general use type of token. And then there's also this concept of what we call generic secrets, which we use Copilot to help us identify what those secrets are. So they could be, what you commonly associate with passwords, upper, lowercase letters, numbers, special characters, things of that nature. And so we'll use AI to help identify some of those patterns that would be more difficult to find via like a regular expression. And that will gives us the ability to provide those results to you so you can see what those would look like in your repositories, or at least the alerts in the repositories. And then you can work to remove them afterwards. And then we also have the concept of custom secrets. So you can create your own regex patterns to find the specific things you want to find. So if you want to find like PII or social security numbers, or you have your own patterns for secrets, for example, you can create those with custom patterns and then have those be identified in your repositories, and also have push protection for those patterns as well. So really quickly throughout this entire presentation, if there is an audience here, that's great. If there's not, that's also great. But if you do have comments, please feel free to drop them in the chat. And then once we get to a good stopping point, I'll go ahead and respond to them. So we've talked about what are the elements of GitHub Advanced Security, from our software composition analysis, from our code scanning, as well as our secret scanning. So all of that sort of bubbles up into what we call our security overview. And that's what we have here. So the security overview is going to give us an idea of what our risk profile is for our organization in this case. And if you look at things from a GitHub perspective, you have your GitHub Enterprise, which is your top level. And then under your enterprise, you have multiple organizations. And then in each organization, you have multiple repositories. And so some of our customers, they'll have the lowest amount of organizations possible to make things really easy to control and to manage. Whereas other customers will use a lot of organizations, like every team has an organization. Or other customers are more methodical on the separation. So like this business unit has this organization, all repositories under that organization are within that particular business unit. So it's pretty flexible. So if I'm going to be looking at security issues, I can see security issues from a repository level. I can see them from a organization level to see all repositories that go underneath. And then if I'm an enterprise admin, I can see everything in the entire enterprise, every organization, every repository. So that gives me an idea of how things are going over time. So you can see open alerts over time. Obviously, we want this not to be going to shooting up to the right. We want it to be going down to the right in this case. So we're actually remediating and removing these types of issues from our code bases. But we also get other types of information, like, what is the average age for the alerts within this particular space, or how many alerts actually get reopened, and how many secrets are actually getting bypassed via push protection. Like, so we get push protected, a developer says this is a false positive, like this is not something that is an actual secret, I want this to be in the repository. You can have that be reviewed by somebody else, and then that secret can be bypassed. But we also want to make sure that we're keeping track of that. We don't necessarily want that to go wild and have a bunch of secrets in our repositories that we actually don't want to be in there. And of course, if we're looking at like where the most risk is coming from, we have these 3 repositories in this organization, and you can see the Java one has a lot more issues than my JavaScript one is and my Python one. I can also take a look at, excuse me, you can also take a look at all of the different CV advisories that we have, or we have identified via the different types of scans that we provide. And then, of course, static analysis vulnerabilities. We kind of, correlate them and put them all into one specific space. So you can see that here we have 16 open alerts for this particular type of vulnerability that's found via CodeQL in this case. And then obviously what CWE is associated with that particular issue. So we see the detection piece. Now let's talk about remediation. Like, how many of these are we closing over time? How long does it take us to close them? What is the net resolve rate? And like, what is the alert activity? Like, are we seeing a lot of new ones being added? Are we seeing a lot of things being closed? Or are we seeing like a stagnation? Like, we're not really adding new things, but we're not really fixing anything. So we're just kind of moving along as a boat down the river. Like, we're not really directing where the flow is going. And then obviously we want to care about prevention. So in this case, we want to see what sort of things we can catch at the pull request level. So if you're not familiar with what a pull request is, it is a space where a developer can go ahead and suggest new changes for a particular code base. And so if I have my copy of my code and there's already a copy of code that already exists, and I want to merge those things together, I do that via a pull request. And in the pull request, we can run a number of automations to check the code, to test the code, to make sure the code follows like our quality standards, the code is not introducing new vulnerabilities, all of those types of things. And it's also the place where other developers can review the code base and say, oh, these changes that you're making, if you can make these changes to those changes, that would make it more compliant, or it would make your code more readable, or it would make things a little bit more efficient for what the goal of what your intention is there. So when we're looking at from a CodeQL perspective, we can scan the code base at the pull request and then tell you, here's your vulnerabilities. But on top of that, we can also say, of these vulnerabilities, here's how you fix them. And we will introduce these fixes in that pull request as well. And that's what the Autofix suggestions is referring to. And I'll show you that as we get further down along this demo. But I'm just kind of showing you things like how everything bubbles up to this point, and then we'll kind of like break things down as we go along with this demo here. Now, the key thing that a lot of people are going to wonder about is, well, how are we actually using each of these different tools? And are these tools actually being utilized? So we want to see, the enablement, like how many repositories are turning these things on. Are we seeing a positive in enablement, or are we seeing like these things being turned off? I also want to see, what the metrics are in terms of pull requests. So, what sort of things are we seeing in terms of pull requests? What sort of things are we fixing? Are the auto fix suggestions actually are working for our developers, and are they actually accepting them? So that way it kind of gives you a sense of like the return on investment for using CodeQL, for example. And then for secret scanning, what sort of activities have happened with secret scanning over a period of time? Are we seeing that we're bypassing a lot of secrets, or a lot of people are requesting bypasses? Are we seeing that um, some repositories have more secrets being pushed to them than others? Is that an opportunity for us as a security team to talk to that development team in particular and say, hey, we're seeing that you're doing this type of behavior. Maybe don't do that, or this is a better way of doing things. Here's how you can use our internal secrets vault, for example. There's a number of different things that you can do with that. But the idea is that you have to have the right information in order to make the right decision. And so this is meant to help you get to that point. Next, we have a number of places where we have different types of alerts. And you do have the ability to, sort the alerts, and also, focus in on more like severe type of critical alerts, for example. This is all going to be from a software composition analysis perspective, or in this case, a dependent bot perspective. And so I can see any of these different ones. But dependent bot, if you configure it this way, can also push these particular fixes for these particular alerts. So for example, if I look at this one, and I just kind of jump in here, I'm not sure if this one actually has a update, but it does say I can go ahead and create the security update from here. For the most part, we do that automatically, so it's not something that you would have to do normally. But if you do want to specifically update a particular one, you can make that from here. The idea is, if there is an upgrade path available, we want to make sure that that is made aware to the developers so they can go ahead and address those as quickly as possible. Next, we have code scanning. And so, as I said before, code scanning is that sort of like platform or umbrella where you can put a lot of other things into it. In this case, the only tool that I'm using right now is CodeQL. But if I want to use JFrog or Endor Labs or Code Secure or some other types of tools that do static code analysis in one way, shape, or form, or provide additional data on my code base, I can have that all be uploaded to here. And so through here, I can, obviously sort things out, kind of see like, what repositories have these types of alerts, and then just kind of see like, hey, I want to take a look at one of these alerts and say, okay, so this is what this is, this resolving XML external entity in a user controlled data, which isn't grand. But with Autofix for CodeQL, If I'm looking at this particular vulnerability, I can click on this button and it'll go ahead and provide me a fix so I can go ahead and address that. I don't want to do that just yet, just in case it doesn't work, which also kind of, forget it. I'm just going to do it. This is, what was that phrase? You only live once and you only demo once live in front of an audience of 40 something people. So let's make it work. Let's see what happens. And if it doesn't work, I have an explanation for that. And if it does, then it does. Hooray. So what we've done here is we clicked the button and we said, hey, we want to be able to fix this. Give me a suggestion on how we can fix this. And so we'll take this information, the alert, we'll also take the code base that's associated with it, and we'll use them as tokens to feed over to our model and to say, hey, how would you fix this with this information? The output comes back to us, but we're not just going to give you the raw output. We're going to filter that down to make sure that the output actually makes sense, that is in the language that is where this particular vulnerability was written and made available. And we also make sure that there's no like other potential issues along with that. So what we can see here is that we're fixing it by changing the code from the right, and we're adding these things to the left. And so what I can say is, well, if this works for me, I can go ahead and commit this to a new branch. If it doesn't work for me, then I can still commit this to a branch and make changes. But the idea here is if a developer doesn't know how to address this in particular, they can use the autofix as a jumping off point, as a way for them to get a better idea of like, well, how do I fix this? Well, this is an example of how I can fix this. Well, let me just edit this a little bit for me to get to a remediation faster. And that's the whole point of us using AI within the GitHub platform as a whole, like Copilot this, Copilot that. All of it is meant to help with developer acceleration in terms of accelerating their productivity. And part of that productivity is also making sure that the software is secure. So we're using AI to help us accelerate the remediation of the issues that we find here. Now, this isn't necessarily limited to CodeQL, right? We have, as I said, other tools can go ahead and integrate into code scanning, but we also have this concept of security campaigns. So before I get into security campaigns, I do want to touch on secret scanning a little bit and just kind of look at those alerts and just kind of show you like what this stuff would look like. As you can see here, we have a couple of, access keys, IDs, personal access tokens. And so we also are able to sort of highlight if these things have been publicly leaked, as in they have been seen in some public forum, one shape or another. And so if that's the case, that's a bad thing. We want to make sure that, we don't have any sort of secrets that have been leaked. But we also want to know, is this an active secret? Yes or no? So with GitHub, we have made partnerships with some of the different partners that we've had for those partnered patterns. And we basically have a secure API endpoint that says, hey, is this an active token? Yes or no? And if it is, well, that helps with prioritization, because if it's active, I need to make sure I rotate that as soon as possible. But if it's inactive, then I can kind of put that on the back burner a little bit, because it doesn't necessarily have any connection to anything. It's not like a key that will fit in any sort of lock. But if it's publicly leaked, to me, that also means like, okay, we need to make sure that this is removed out. Like, for the token that this was meant to represent, have we rotated that? And if so, or if not, rotate it as soon as possible. So the idea is to sort of ignite a process internally to make sure that these tokens are taken care of. And then if we look at the experimental ones, you can see here that there's a number of different types of sort of password combinations that we have here. And we used AI to help detect a lot of these. And there's going to be others, like you can see here, the HTTP, bearer tokens that we see over here. We also, those are what we call those non-provider patterns, whereas these are what we call our generic secrets. So these are the things that are a little bit harder to identify with a regular expression, but contextually, they are able to be found easier with Copilot in this case. Next, let's talk about security campaigns. So, what a security campaign is, it's meant to help tackle the problem of technical debt. So, if I have a ton of different vulnerabilities, and what I want to do is I want to be able to have my developers work on a certain set of them that I deem as more important, as to have a higher priority to be fixed. I cannot expect developers to work on 1,000, 2,000, 3,000, 5,000, whatever sort of issues. That's daunting. That's a lot. They have other things that they have to worry about. But if I'm able to narrow things down to a critical level, or to narrow things down to specific repositories that have a higher business criticality for our organization, if I'm able to narrow it down to known exploited vulnerabilities, then I can say, well, of these 1,000, 5,000, however many it is, I care about this smaller chunk, and I want this smaller chunk to be fixed by a particular date. So I'm just going to create a new campaign so you can kind of see what that looks like. And so you can see here we have a couple of templates where we say if you want to see critical code QL alerts, or the MITRE top 10 known exploited vulnerabilities, SQL injections, cross-site scripting, or you can create your own filters. And there's a number of different filters that you can use to help sort of narrow down the types of vulnerabilities that you'd want to be able to get fixed. So I'm just going to say SQL injections, for example, I want to get those fixed, and I can get them fixed by March 31st, next month, the end of next month. As a campaign manager, I can review this, I can make the changes, and if anyone needs to contact me about anything that they have within this campaign, I can provide a link on how to contact me. Once that's done, I'll look at something similar to this, since I've already created this campaign. And you'll see that we have 12 different vulnerabilities in 2 different repositories. Most of them are coming from my Java one. And you'll also see that of the 12 of them are supported alerts with Copilot Autofix. So here's the cool thing with security campaigns. Earlier, you saw me look at a code QL alert and then have to click a button that says generate fix, and it gave me the fix there. With security campaigns, we automatically start applying those fixes to the alerts here. And I don't mean like applying them as in adding them to the code base. I mean applying them in the alert that for that to be reviewed. So for example, if I look at this one is this is actually an AI generated as of yesterday, because that's when I created this entire environment yesterday. But what you can see here is I have my alert. I can see, the data flow for this particular alert, so I can review that and understand, like, okay, where does the data come in and where does the data come out? What is the source and what is the sink? And then here is my potential fix. I can go ahead and say, hey, I'm going to actually use this. This can actually work for us. Or I can say, you know what? I'll take this, but I'll make some changes to it. And so again, it's supposed to be a way to help accelerate remediation of these particular issues. Now, once these things start happening, like these types of actions, you're actually going to be able to track that as like icons over here. So if there's a current pull request open, you'll have like a green sort of pull request icon. If the pull request has been merged, there'll be a purple one. And then if it's once it's merged and we've done another code QL scan and we've identified that this issue no longer exists, then we can say that is one alert completed. And so as the security manager, or in this case, the owner of this particular campaign, I can see this progress bar go up and up and up as these things are worked on. And the things that aren't worked on, that as we're getting closer to the end of it, I can go to the developers and say, what sort of help do you need from me in order to help fix these particular things? Like, what can we do internally? Do we need to, rush to get more resources on this? Or is there something that I can do to assist? Anything like that, at least it gives me a way to communicate with them and also have a deadline to help sort of inspire that sort of activity. I say inspire, I think it's more encourage, motivate, something like that. Light a fire under people's butts, for example, is a phrase that I hear quite often. So yeah, this is security campaigns. It is a very strong tool that allows security people to help collect a chunk of alerts and have that feedback go back to the developers, provide auto fixes for what we can auto fix, and then developers can go ahead, take that information, and then apply it and remediate it. And now that issue is now, we have less issues than we did before. So this is all from the security tab in GitHub. I don't expect developers to spend much, if any, time in this particular view. This is more relevant for security professionals who are managing the application security and want visibility into what developers are doing, what they are producing, what they're remediating, what they're fixing, what they're addressing, then also help guide them on how they can address these things, how quickly they need to address them, and what needs to get addressed at what time. So let's actually talk about it from a developer perspective. So if I'm going to be interacting with Dependabot, I'm going to be looking at the pull requests that come from Dependabot. If I'm interacting with CodeQL, it's going to all be in the pull request. If I'm going to be interacting with secret scanning, I'm going to be told where those secrets are, and then I need to do something about that. So let's actually look at things from a developer perspective by looking at a repository. So I will go ahead and start our journey here. And I'll go ahead and start with secret scanning since it's probably the most the easiest one to sort of like showcase and also the easiest one for to turn on. I mean, it's very, very fast to turn on. It's very, very fast to get information. So it's very quick to value. But the key thing I want to showcase is like, well, if I'm a developer and I have a token in my code that I'm adding to my code base here, what happens? So actually let's go through that. So I'm gonna go into my settings here. I hope you love that image. It was generated with AI. And we have, we'll go into our developer settings. So what I'm gonna do is I'm gonna create a personal access token in this case. So from here, I'll go ahead and do all the security stuff. I'll just call this one Reactor token. And all of you here on YouTube and LinkedIn, you're going to be able to see this token. So you better copy it as soon as possible. So that way you can get access to all the things. I'm just kidding. Please don't do that. For the love of God, don't do it. I'm going to go ahead and have this expired on Valentine's Day. And I'm not going to give it any permissions because all of y'all are going to be able to see this. So that sounds like a dangerous situation. I'll go ahead and generate my token. And I'm going to copy it. Now's your chance. There it is. All right. So I'm going to go back to where I was before. Should have, what's the word? Open that in a new tab. Here we are. So I'm back into my repository. I have my token in my clipboard. And what I'm going to do is I'm just going to open up any sort of file here. I'll go into my index.js. I'm going to edit the file. And I'm just going to type out let token equals that token. There it is again. All right. So now what I want to do is I want to commit this. So let's just say, for example, this is some new code that I'm introducing to this project, and I want to see if, push protection is actually going to stop me. So I'm going to commit directly to the main branch because I'm a bad developer and I do bad things, and I'm blocked. So this type of messaging and this type of activity, this isn't limited to the UI. Like I don't expect developers to actually write code in the browser. I expect them to write code in their IDEs. And if they're real hackers, do everything in Vim or NeoVim. Whatever sort of Git client that they're using, this type of messaging is going to show up in that Git client. So whether that Git client is on the CLI, whether that Git client's inside the IDE, or they're using some sort of graphical user interface for Git, they will get a response. So the way this happens is whenever a developer is pushing that code, it hits GitHub, and then we run Git as an event-driven type of tool. And so we have a pre-receive hook that will go ahead and isolate the code base, run a secret scan on that code base, on that commit, and then say, what are the secrets that exist in there? And if we find that a secret does exist in there, then we respond with this type of response that we found a secret on this line in this location and it needs to be removed. So please recommit this commit without the secret there. That allows us to prevent that secret from being added to the Git history. Another big question that people tend to ask is, well, if we're doing secret scanning, are we doing just secret scanning on the, what's the word, on just like the current branch or like on the main branch? The answer is no. We're doing a secret scan on the entire Git history. We are also doing a secret scan in places like issues and discussions, in a lot of the places where developers are adding text to GitHub. That's where we're performing a secret scan. And so that way the security can see, like, hey, we're seeing all these sorts of secrets being found in these types of areas. Let's go ahead and prevent that from happening. In this case, we're preventing it using Git. So now that I can't use this anymore, I'm going to go ahead and cancel changes and say okay. And you know what? Just because I am like crazy paranoid right now, because I just invited a whole bunch of people to take my token and just do crazy stuff with it, I'm going to go ahead and delete it. And this one too. So that's done. My anxiety has been reduced significantly. And that's secret scanning push protection. And as I said before, you can create your own custom secrets, and you can use those custom secrets with push protection as well. But for like the AI generated ones, it's not supported for push protection, and it's for a pretty good reason. You don't want every commit to be blocked. You don't want developers to have that sort of really negative and high friction type of interaction with GitHub, because their job is to push code, to create new features, to fix things, to get things moving as quickly as possible so that the business can continue to grow and function. But if we're just stopping developers right and left, it's not a good look. It makes things more frustrating for them. They're not able to meet their goals. They get yelled at, all of this stuff. So the idea with like the AI stuff is like, well, we want to be able to catch those when they're in the repositories, and we can go ahead and remediate after the fact. But if we do that from a push protection perspective, we might hit a lot more false positives than we want. And so we want to make sure that we at least have a 99% surety, assurance that the whatever we're blocking is a true positive. So that's why we work with these partner providers, and a lot of those are the ones that can get blocked with push protection. Okay, so that's going to be from a secret scanning perspective as a developer. What about CodeQL then? If I'm going to be pushing in new code to the repository, what happens with that, right? What sort of checks can we run? What sort of activities can we see? So I have all of that already done via a pull request in my Python application here. And so what I've done is I've updated a particular file, and in that file, it found a log injection vulnerability. So this is the pull request. So I've made changes to the code base, and I've gone ahead and created a new branch here called my username patch1, and I want to merge that into the main one. But beforehand, I need to make sure that I pass certain checks. And so over here, you can say like, hey, we found a potential problem. This is the problem. You can go ahead and see the show paths here to see what that data flow looks like. Pretty cool, right? Now, as a developer, I'm like, well, what do I do about this? Like, how do I fix this? And how do I do this quickly? Well, here's Autofix. And Autofix is basically saying like, well, to fix this type of injection vulnerability, you would essentially, remove some of those special characters out of there. But I can say, you know what? This fixes part of it, but I don't think we should be taking user input and then just directly putting it into a log. Like maybe we can log the event, but not the actual input and the information. So I can go ahead and say, I'm going to edit this, for example. And from here, instead of like taking this example for instance, I can go ahead and add new code to say, well, I just want to say that this event had happened, and then just have that be logged somewhere. And that way we can completely avoid the log injection vulnerability. But to help me get to that point, the Copilot Autofix is there to help me get over to that location. Oh my goodness. There we go. And as you can see here, CodeQL ran automatically, um, and I was able to get that information. We got the autofix. Now I can collaborate. I can make the edits. Then I can go ahead and say, you know what? Let's commit that suggestion. Let's commit those changes. And then once that happens, you'll see a new commit here from both me and Copilot. And then we're going to run the CodeQL checks again to make sure that this fix actually addressed the issue. All right. So that's from a CodeQL perspective on like what I expect developers to really sort of be working with and what sort of experience I expect them to have. If I look at my Java application again, and I want to see things from like a software composition analysis perspective, what if I am introducing new vulnerabilities with my changes to my manifest file? Like if I'm trying to add a new open source component to my application, is there a way for me to make sure that I'm not adding in something that could be problematic? So I've done that already. It's kind of like one of those like those cooking shows where like they show you how to mix something, and then like underneath the counter is like, oh, and here's the cake. Like you don't have to bake it. You don't have to sit here for 40 minutes and watch me just stand around looking at an oven all day. I've already done it. That's the magic of live streams, I suppose. But here is my pull request. I'm updating my pom.xml, and I've used a workflow called dependency review. And dependency review is going to run at the pull request stage. And what it's going to be looking for are instances where the manifest file is changed. And of those changes, are we introducing additional risk to our application? And in this case, we can see, hey, are we introducing packages with unknown licenses or incompatible licenses that our organization cannot use because of legal reasons, right? We don't want to get sued later on and have to, shut down our application until we can actually make this change. I want to make sure that we are compliant from day one as opposed to day 100. But from here, we are adding in this log4j type of package, and we can see that there's multiple vulnerabilities for this particular package. And so we were blocked in this case from adding this because this, in this case, is not something that we should be adding to our application because it will be adding additional risk and additional problems that need to get remediated at a later time. So you can see, like, from a developer's perspective, a lot of this has to do with things that they're already doing. They're already making pull requests. They're already pushing commits. They're already working on code. The feedback that they get from this is meant to help them make better security decisions for the code that they are writing. And it's a lot easier to have this centralized in one place via inside of GitHub where the code lives anyways, in order for them to be able to get that information and make the right choices in a most efficient and effective way possible to prevent issues from being found later on and a much more expensive prospect on actually fixing and addressing those issues. Okay. Another thing we can look at are some of the dependabot, changes that we've made here. So I can just kind of like look at these. It's pretty clear like what sort of things are happening here. But in this type of dependabot alert, we are essentially updating 7 different packages. And instead of having like one, pull request per package, this allows us to group these updates together and send them over to or update the packages in our repository. So we're reducing the amount of risk from an open source component perspective. And as you can see here, it kind of lets us know that there's 2 packages with open SSF scorecard issues and one has unknown issues. So even with these dependabot PRs, we still have dependency review running, letting us know that, hey, is dependabot, sending this stuff over to us, and are these, potentially adding additional risk? Well, in this case, in terms from a vulnerability perspective, It's not something that we are adding. We are actually fixing these issues and reducing that risk level, managing the risk, I should say. Okay. So we've talked about dependency review, we've talked about dependabot, we've talked about pull requests, we've talked about code QL and autofix, we've talked about secret scanning, and we've talked about push protection with secret scanning. I think ultimately, what we are really here to set out to do with GitHub Advanced Security is, since the code already lives here and it's already being worked on, it's already being collaborated on, everything is already happening within this space. What we want to be able to help accomplish is, how can we help developers be more efficient and help take less time sort of like fixing these issues, automate as much as possible, and use AI specifically from Copilot to help fix some of these issues so we can actually get this stuff done quickly, and so developers can get back to doing what they do best, which is building, which is solving problems, which is making the world a better place with software. I don't want to debate whether or not, the internet was a mistake, but since we have it, we want to make sure that we're trying to be as secure as possible. Okay, so for now, that pretty much concludes the demo portion of GitHub Advanced Security. As usual, if you do have more questions, please feel free to drop them in the chat. I'll go ahead and answer some of the questions that I see now. And, if you do want to reach out, please reach out to us at GitHub. We're more than happy to, help out there. All right, so let me see what sort of questions that we have here. So we have one. Does this scanning available in Azure repos or Azure DevOps repos, or um, yeah, Azure DevOps and the repos within there? There is a feature called GitHub Advanced Security for Azure DevOps. And some of the tools are a little bit different, and some of the tools are pretty much the same. So from a code scanning perspective, or at least from a code QL perspective, you would be using code QL inside of GASDO, what we call GASDO, or GitHub Advanced Security for Azure DevOps. In terms of the dependencies, they use something called dependency tracker, and we use dependabot and dependency graph and all of those things. So it's a similar sort of approach. And then for secret scanning, they also have a little bit different type of secret scanning tool, but it functions virtually the same thing. So you'll be able to see these types of alerts inside of GitHub Advanced Security for Azure DevOps, or specifically you can see these things in Azure DevOps and get some of that value there. And I think that was the only question that we had today. So cool. Well, I appreciate you all being here. Again, if you have more questions, please feel free to let us know. I will give it back to Anna to help wrap this up. So back to you, Anna.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.